Hi. Today we're looking at factoring the greatest common factor. So we call that the greatest common factor, the GCF. So first let's review what we did the other day. So the other day we were multiplying a polynomial, so a monomial times a binomial. So doesn't this mean we're multiplying 4 times x, which gives us 4x? And then we're also multiplying 4 times 2, and that gave us a positive 8. And so today what we're actually learning is we're going backwards. What if I give you the answer and I want you to go back and say, what am I hiding? So what if I hide the original question and I actually want you to go in reverse and I want you to go backwards? That is known as factoring. So we're basically just re-engineering the distributive property. So when we're factoring, we want to look for the greatest common factor. So we want to look for a number that divides into 4 that also divides into 8. And we want the greatest one. And so while 2 goes into both of them, right? 2 times 2 is 4. And 2 times 4 is 8. That's not the greatest. 2 is in common, right? It's common with both of them. We want the greatest common factor. And can't 4 be written as 4 times 1? And can't 8 be written as 4 times 2? So don't they both have a 4 in common? And that is known as the greatest common factor. So 4 is the GCF. So remember, 4 is the greatest common factor. That's what was in common in both terms. So they both terms could be divided by 4. So 4 is the greatest common factor. And that's the monomial that gets pulled out in front of the parentheses. Then we're basically just reverse engineering. Remember, we were multiplying the first 2 together, and we were trying to write whatever this was had to give us 4x. So what would have to go in that yellow question mark that 4 times what would give us 4x? So wouldn't this have to be an x? And then didn't we multiply 4 again times the next term? And didn't that have to give us an 8? So 4 times what would give us that 8? So wouldn't this have to be a 2? And obviously a positive times a positive is going to give us a positive 8. So we are working backwards. So another way of looking at it, here's another way of looking at it. Can't 4 be written as 4 times x? And can't 8 be written as 4 times 2? And then the 4 is what we put out in front, right? We put the greatest common factor was our 4. So that means what's left, because we took the 4 out and we took this 4 out in front. So what's left is the x and the 2. So that's another way of looking at it. So we're working backwards. So let me give you another problem. So what if I had say 9x minus 12, and I want to factor that. So I want to know what is the greatest common factor, and I'm going to reverse engineer the distributive property. So what is 9 and 12? What do they both have in common? What number will divide into 9 that will also divide into 12? And we want the greatest number. So wouldn't that be 3? So 3 is going to be our greatest common factor. And then we just have to reverse engineer and think 3 times what could we multiply that would give us 9x? So wouldn't this have to be 3x's? Right? Because isn't 3 times 3x give us 9x's? And then what could we multiply by that would give us negative 12? So 3 times what gives you negative 12? Wouldn't that have to be a minus 4? So this is our final answer. So if you were going to type this into Canvas, so if you have a teacher that's working with Canvas and they ask you to factor, you always put the monomial, the GCF, the greatest common factor, should always be out front. You have to have a parentheses, and you have to make sure you end your parentheses with no spaces. So if you don't end your parentheses and you forget to type in your last parentheses, it's going to mark it wrong. Your GCF always has to go out in front. So you got to make sure that you're typing your parentheses, and always, for my class, no capital letters, and make sure there are no spaces, or it'll be marked wrong in Canvas. So let's try another one of those, going backwards. So here we have 5 times x squared minus 10x plus 15. When we multiplied this, didn't we multiply 5 times x squared and we got 5x squared? And then didn't we multiply 5 times negative 10x? Didn't that give us negative 15x? And didn't we multiply, oops, I'm sorry, I don't want to do 15, that's too big. Let's do, instead of 15, let's do 3. And then 5 times 3 would give us 15. Sorry, 5 times 10, got ahead of myself. 5 times 10x is 50x. And then 5 times 3 is 15. And then 5 times x squared is 5x squared. That's what we did the other day. The other day we were multiplying polynomials. Today we're doing what's called factoring. And today I'm giving you the answer, and I'm asking you to tell me what was underneath this black square. So we are actually working the other direction and going backwards. And again, that is called factoring. So how you factor is you want to pull out the greatest common factor in all 3 terms. So what number goes into 5, that goes into 50, that goes into 15? And doesn't 5 go into all of those? And isn't that the greatest common factor? So 5 is our greatest common factor. So our greatest common factor comes out front. And then you have to re-engineer, so we're reverse engineering the distributive property. So 5 times what would have to go there to give us 5x squared? Yes, you're right. It would have to be an x squared. And what's nice about these problems is you can always double check yourself. But you have to know how to multiply polynomials. Then we're thinking, think. 5 times what in the middle is going to give us negative 50x. And wouldn't that have to be a negative 10 x's? And then 5 times what is going to give us positive 15. So what would have to go in that last slot to get positive 15? So that would have to be a positive 3. And then we could double check it and make sure does 5x squared, when you multiply that, really give you 5x squared? Check. When you multiply 5 times negative 10x, do you get 50x negative? Yes. And when you multiply 5 times 3, does that really give you 15? Yes. So you can double check it by multiplying out to make sure. So again, today's lesson is about factoring. We're going in the opposite direction, and we are factoring out the greatest common factor. So if you have 12x to the 5th power minus 8x squared, we look at and see what is the greatest common factor. They both have a 2 that can divide into them, but 4 goes into 12, right? 4 times 3 is 12, and 4 times 2 is 8, so they have a 4 in common, and that's the greatest common factor. So we have to pull out a 4, so we have a 4 coming out. But what about the variables? What about the variables? This one has an x to the 5th, and this one has an x squared, so they at least both have at least an x squared in common. So we're actually factoring out the 4 from the 12 and the 8, but the x squareds and the x to the 5th both have an x squared at least in common. So that is our GCF. And then when we reverse engineer, 4x squared times what is going to give us 12x to the 5th back? Well, obviously you need a 3 because 4 times 3 is 12. And then we have x squared, and we need to get to x to the fifth, so doesn't this have to be x to the third? And then what could you multiply by to get to this last one, to get negative 8x squared? So wouldn't 4 times negative 2 make that negative 8? And then we already have x squared, so we don't need any more x squareds. So that's your final answer. So if you were using Canvas and you needed to type that into Canvas, you would type in 4x, you would use exponent key squared, parentheses, 3x, exponent key 3 minus 2, end of parentheses. So that's how you would type in 4x squared, parentheses, 3x to the third power minus 2. If you were using Canvas and you had to type it in, you have to use the exponent key for the squaring. You have to use the exponent key for to the third power, right? So that's how you get the x to the third power. And that's how you get the x being squared. Okay, this is just a little short video on factoring and factoring out the greatest common factor. Some problems are a little bit easier than others.